All right, last section in this module. Awesome. So section 1.3, your learning objectives. So you're going to measure the center with the mean and the median, measure the spread with standard deviation, interquartile range, possibly the range, identify outliers, construct a box plot for using the 5-number summary, calculate numerical summaries with technology. Yay, here we go. So to find the mean, and we kind of talked about the mean looks like this for a sample. So it's pronounced X bar, and that's where we can find in our calculator after we did the one variable statistics. So you add up all of the observations and divide by the total number. So in mathematics, the Greek capital letter, this guy right here, is meaning to add them all up. So you could actually write the mean, the sum of all the x's, divided by the total number, where you use that guy for meaning to add up everything, so to sum. Different symbols for the mean. If you're dealing with a population, your mean is mu. So when you make it, it's like, it's not an M, it's a U with a tail, okay? So you have your U with a little tail right here. And for the sample we've talked about, this is an X bar. So whenever you're dealing with populations, all of those symbols are going to be Greek letters, so you can think populi, okay? But whenever we're dealing with populations, all the symbols are Greek letters. And then the samples are just different. So get this down. Population mean is mu, and for a sample, it's X bar. So sorry, really quick joke. I gotta just tell you really quick. So you have little cows. It says, what do Greek cows say? Greek cows say mu. Okay, sorry about that. All right, so measuring the center with the median. So the median is a midpoint of a distribution after everything is put in order. So to find the median, the first thing we want to do is arrange all the observations from smallest to largest, so ascending order. If the number of observations is odd, the M is just the center. If you have an even number, then you will have two centers, and you just take the average of the two. So the mean and median are both measures of the center, and they're both useful depending on what's going on. Excuse me. The mean and median of a roughly symmetric distribution are very close together. So if it's roughly symmetric, your mean and median should be right in the middle, pretty close together. If it's exactly symmetric, then they're exactly the same. If it's skewed, the mean is going to follow the skew more. So here, if it is skewed left, your median may fall here, your mean would be here. So the mean gets more affected by the skew than the median. So think about like all these data pull the mean a lot more than the median. Okay, and if it's skewed right, the median and the mean, so the mean gets pulled farther again from that skew. And again, the mode is just always that highest peak. So here you can kind of see skewed left, skewed right, and symmetric, what ends up happening. And this is really important to know. So if you have skewed data, you want to use the center that is less affected. So if your data is skewed, you would pick the median for your center. If it's symmetric, usually we take the mean. So with the density curves, they always are going to have an area of 1. So the area under the density curve, regardless of what it's going to be, is always going to have an area of 1. And you can think that this is 100%. Okay? The median divides data into 2 halves. So wherever that median is saying that the area under on the left side is the area same as the area on the right side. So they're both 50% of the data. The mean is the balancing point. So wherever the mean is going to be is what ends up balancing. Okay, so just again, a little bit of a summary if you want to read through this. So the interquartile range. So to calculate quartiles, arrange all your observations in increasing order and locate the median. So do that first. Since the median splits your data into 2 equal halves, so you'll have 2 equal halves after you take that median. With the left-hand side, go find the median of that. That's actually your quartile 1. With the right-hand side, go find the median of that. That's your quartile 3. Okay, so your median overall data is your quartile 2, the median of your left-hand side data is your quartile 1, and the median of your right-hand side data is your quartile 3. To find the interquartile range, you take quartile 3, your upper quartile, minus quartile 1, your lower quartile. So quartile 1 is also your 25th percentile. Quartile 2 is your 50th percentile. Quartile 3 is the 75th percentile. So what that means is that 25% of the data lies below quartile 1, and etc. for quartile 2 and 3. So your IQR is the middle half of the data. So that's the middle 50% of the data when you're dealing with the IQR. So again, when we kind of split up our data, this guy right here, remember that was like quartile 1, quartile 2, quartile 3? This is 50% of your data. And then this out here, with this out here, would be 50% of your data. Okay? So let's find and interpret the IQR for the data going on here. So I put it in increasing order. I had 2 middle numbers, so you have to find the average of the 2, and there's your median, or quartile 2. Then over to the left-hand side, after you've split that up, again you had 2, so you take the average, and I got 15 for my quartile 1. On the right-hand side, you have an even amount, so you have to take the average again, and I got 42.5. So my interquartile range would be quartile 3 minus quartile 1, which is 27.5. So the interpretation, the range of the middle half of travel times for the New Yorkers in this sample is about 27.5. So 50% of the data falls between 42.5 and 15. All right, outliers. How to determine if there is an outlier. So this is 1.5 times the IQR, and you will have to memorize that. It's not on your formula sheet. So 1.5 times the IQR. If you add that on to your quartile 3 or subtract it from your quartile 1, anything outside that range is going to be an outlier. So again, I would take quartile 3 plus 1.5 times my IQR, and I see, is there anything above? Or I could take 1.5 times my IQR and subtract it from my quartile 1, and I see, is there anything below? If there's anything above that or anything below the second part, then those are outliers. So I want to know, are there any outliers from the previous example? Looks like I can't spell pervious. That's supposed to be previous example. So let's see. 1.5 times my IQR is 41.25. Quartile 1 minus that was negative 26.25. There was no other data below that. Quartile 3 plus your 41.25 is 83.75. 85 is above that, so 85 is an outlier, and that's the only outlier that you have. All right, your 5-number summary So whenever a question would ask for a 5-number summary, you need to do these 1, 2, 3, 4, 5 things. And it's basically just the components of a box plot, or box and whiskers plot, however you learned it. So the minimum, the quartile 1, the median, which is the quartile 2, the quartile 3, and the maximum. And that's your 5-number summary. So the 5-number summary divides the distribution roughly into quarters. This leads to a new way to display your quantitative data, the box plot. And again, lots of you learned that it's called the box and whiskers plot. We're going to just use the term box plot. Draw and label a number line that includes the whole range of the distribution. Draw a central box from your quartile 1 to your quartile 3. Put the M as a line down the center, so the median or the quartile 2. And then extend the whiskers from the outer quartiles to the maximum and the minimum values. So let's see. Here you can see you're going to draw a box around your upper and your lower quartiles. Draw the line through the median. And draw the whiskers from the upper and lower quartiles to the max and the min values. And you always have this number line that encompasses all the numbers that you have. All right, so box plots. How do you know if they're skewed right or skewed left? So basically, you know your median is roughly there, and then it goes down something like this. And on this one, it would look more like that. So after I draw those density curves, it's a little bit easier to see. Again, there's where my little small guys are, and here's where my big guys are. So this one is skewed right. Here's where my little small guys are. Here's where my big guys are. So this one is skewed left. All right. So statistically, the distance from your quartile 3 to the maximum is much greater than the distance from your quartile 1 to the minimum. And this is a really great way to provide your evidence. Let me erase this for you so you can see what we're talking about. Okay, so when you see the distance from quartile 3 to here, versus quartile 1 to the minimum, you can see that this has a much greater distance. So here you can see that this one would be skewed right. Same thing over here. This distance is bigger than this distance, so this is skewed left. All right. Make a box and whiskers plot or a box plot for the prices of statistics books in dollars. Go for it. I'm going to do it in the calculator. So I'm going to enter all my data into list 1. I'm going to go stat, calc, 1 variable statistics. In my 1 variable statistics, I can scroll up or down, and I can go, when I scroll down, find my min, my quartile 1, my median, my quartile 3, and my max. Yay! There's my 5-number summary. Now that I have my 5-number summary, I want to make sure my number line, and here you can see, I need to incorporate from 35 all the way up to 120. So as I make this from 35, I need to go all the way up to 120, and I just did mine in the calculator. You can do yours out a little bit better by hand. So if I wanted to see it in the calculator only, I'm going to go to second y equals, which is the stat plot. We're going to turn it on, and then you have choices for your box plots. This one right here with these dots, say I want to see if there's any outliers. That's the one I would always pick. So then I'm going to zoom stat. Make sure there's nothing else in your other y equals, or you're going to get all kinds of weird stuff going on. So after I zoom stat, this is what I came up with. So I can see that this outlier shows up as a little dot, but it's not included in the box plot. Hit the trace button on your calculator and move from left to right, and you can see all the values now of the 5-number summary if you include the outlier. So taking out the outlier, your min would no longer be the minimum because this was 35. So if I remove that, then the min is the next lowest value. Now, if you didn't want to show the outliers, then you would have selected that guy. All right, measuring the spread. Standard deviation measures the average distance of observations from their mean. It's calculated by finding an average of the squared distances and then taking the square root. So this is to ensure when you square them that you get something positive. So that way, in this case, if I take the distance, I would get a -4. If I square it, then square root it, then I would get a +4. So it's just making sure it's kind of like an absolute value, but it's just ensuring that you're getting positive distances. This average square distance is called the variance. All right, so symbols for standard deviation. Population, it's kind of like a sideways 6. And again, it is a Greek letter because you're in population. And for a sample, you're going to use S sub x. Now, if you want the variance for a population would be sigma squared. And the variance for a sample would be S sub x squared. So variance is the standard deviation squared. All right, so how you find standard deviation? Well, there's 2 different formulas depending on if you're in a sample or the population. If you are dealing with a sample standard deviation, then when you take your square root, you add everything up, all the distances squared, you take the square root, but you divide by n-1 inside the square root. If you just want the variance for, the standard deviation for the population, you only divide by n. Now your calculator will do both of these. So when you look in your calculator on your one variable statistics, you're going to see 2 different things. This just says Sx in the calculator, and this says sigma x. So the sigma is for your population, and the S is for your sample standard deviation. All right, find the standard deviation for the following data. Test scores for Mr. Rose's AP Statistics class were the following. So let's find it for this one first. Then we'll do the AP Calculus BC class. Excuse me. All right, so the first thing we need to do is go find the mean. So find the mean for the data for Mr. Rose's AP Statistics class. Once I have that mean, what I want to do is take each individual score and subtract the mean and then square it. Add all of those up together and you get a total. Once you have the total, you're going to divide by n-1 and take the square root. And I got 7.5. The reason we did n-1 is because this is from a sample of my class. Now, if I wanted to do it in the calculator, let's do the second one in the calculator. So go put all of Mr. Rose's AP Calculus BC class. Let's put that into list 1. We're going to go stat, edit, enter in list 1, stat calc, go to one variable statistics, and then we want the sample standard deviation. So we're going to choose Sx, and in this case it was 18.19. So here you can see that we had 7.5 and 18.19. So this guy is a lot more variable than 7.5. So your data is going to be a lot more spread out for the BC class. So it means that all of the AP Stats kids were close together. They were more alike. So more alike, another word for that is homogeneous. So they're more like each other. So they're more homogeneous. All right. So now when we have the choice between using the center and the spread, what we want to pick from, let me get that up. All right. The median and the IQR are better when the distribution is skewed, and you could pick which one you want to pick. Or you can choose the median and the IQR when it is skewed, all right? Median, IQR, skewed. If it's not skewed, if it's symmetrical, then usually you use the mean and the standard deviation, okay? Okay. Note, numerical summaries do not fully describe the shape of the distribution. So you can always plot your data, but describe it. While you definitely need to have the numerical value stated, when it asks for other things, make sure you give a good description. All right, so we are done. Section 1.3. We did the center and the spread and the mean and the median and the quartiles and the interquartile range and all kinds of fun stuff. We learned how to find an outlier. We know the 5-number summary and how to make a box plot. We know the variance and the standard deviation. And when to pick, when it's skewed, to pick your median and your IQR. Yay! You did it. Congratulations for making it through your first module. I'll see you in Module 2.